and anything that we don't get to, we will get at the end. Okay, so I think we're just about at 3 after. So I'm going to, in the interest of everybody's time, just go ahead and get started, and people will probably trickle in as time goes on. So let me share out my screen one more time here, and we'll go ahead and get started. As I mentioned, please do keep yourselves on mute. There will be an opportunity at the end for some question and answer. And if at any time during this presentation you do have questions, feel free to just pop it in the chat window. There's a team of experts on my side that'll be happy to answer those, and then we'll do some live at the end rather. So let's go ahead and get started. So in this presentation, we're talking about harnessing the power of artificial intelligence, machine learning, to kind of make an impact on our vulnerability backlog. So in this chart, we'll kind of start off and talk about what it looks like today. So I see this all the time when I talk to folks. They say, hey, Jonas, I scanned. I've got 1 million vulnerabilities. I don't know which ones to work on first. I'm having trouble kind of making an impact on this huge pot of vulnerabilities. And that's what we have represented by this red dot in the lower right-hand corner. And that leads to this concept of a backlog. And it's a backlog because you have this large pot of vulnerabilities. You may remediate 1,000 of them, but as soon as Patch Tuesday comes along, another 1,000 vulnerabilities gets popped on the top of that pot. So it doesn't look like you're making progress. So when we look at it from that perspective, there's a clear issue. So what we want to do, and what we'll show in this presentation, is to prioritize a very few vulnerabilities. And the reason that we do that is because we want to fix the ones that matter first, and it also allows us to make progress in our process. All right, when I have a small batch of vulnerabilities, if I go ahead and fix 10, 20, 30, 40 of them, then I'm starting to make an impact, right? I'm reducing that backlog. As you can see, I've gone from a small dot to an even smaller dot, as opposed to, you know, the chart in the lower right, where I'm not making much of an impact because the scale of the problem is just too big. Okay, so that's a great segue into the scale of the problem slide. These are stats based on year-to-date vulnerabilities from the ThreatWatch platform. So year-to-date, we found 40,000 vulnerabilities that have CVE numbers associated with them and have in essence been disclosed. 10,000 of those have a CVSS rating of 7 and above. And this is where I see a lot of people start. A lot of people say, hey, I've got this big pot of vulnerabilities. I'll take the CVSS score 7 and above to reduce my pot and start working on those. That's part of the solution. There are 7,000 vulnerabilities with no CVE tracking. So these are vulnerabilities, you know, that for whatever reason don't have a CVE. You know, they may not have a CVE yet, or they may never get a CVE, right? It may be something that's not previously disclosed. It may be a smaller application, maybe a specific application specific to your vertical or industry. And if the developer doesn't report it or some security researcher doesn't report it, it's just not going to get a CVE. But those are still a significant risk. There's a lot of them. Then there are 6,000 vulnerabilities with known exploits. We already know these are bad. These are very easy for bad actors to kind of get a hold of and do damage to your systems. So the current woes and the reason for the backlog is in line with that, right? We either have a choice of We can remediate them all, which we all know is very, very difficult to do, almost impossible. We can focus on those critical ones, take the 7 and above or 5 and above or whatever you choose to do and focus on those. Most folks just ignore the non-CVE vulnerabilities. So this is a bad idea because we see these used in exploit kits all the time. But most people, just because of their tooling, don't have visibility into it, so they choose not to remediate it. And then you miss out on this set of vulnerabilities that we know about that are likely exploitable. Okay. So I've got some headlines here, and I'll read through a couple of them. And I'll point out the really important ones. First one, more than 50% of exploits came from vulnerabilities rated at CVSS 6 and below. So the reason why that one's important, right, is because a lot of folks do 7 and above, right? They're just doing high acuity vulnerabilities. But what we see here is half of exploits are coming from kind of those low ones with low CVSS numbers. So if you're skipping those in your process, right, it opens ourselves up to additional risk. More than 30% of reported exploits were referenced or traded on the dark web. This kind of just goes with the theme of undisclosed exploits. If it's in the deep web, dark web, you probably don't hear about it, and your tooling probably doesn't know about it. So it's just important to be aware of. Vulnerabilities highly likely to be exploited are projected to be less than 3% of known vulnerabilities disclosed last year. Vulnerabilities without CVE assignments comprised more than 15% of known vulnerabilities disclosed last year. And then this last one, only 130 vulnerabilities reported last year were weaponized into malware. And I think that's the second most important headline on this slide. That's a low number, right? Especially with the magnitude of those numbers that we saw on the first slide, 40,000, 6,000, 7,000 vulnerabilities. When I look at this, only 130 end up in malware, right? So that's a little hint to what we're going to talk about now. Where we want to get to is get to those 130. That's a population that we can affect, we can work on, and that's completely practical to remediate. Okay, so let's talk about CVSS score-based prioritization. More than 50% of exploits came from vulnerabilities rated at CVSS 6 and below. These are those kind of ones that we don't worry about because they don't have a high enough ranking number. And for those of you that may not be super technical or super close to the vulnerability process, CVSS is just the scoring system we use to say how bad it is. So this is that headline that we have here, 30-day snapshot. There are 2,158 CVEs with exploit, and again, a CVE is just kind of a serial number for that vulnerability. They have exploits, meaning it's easy for somebody to come in and attack you with it. And then lastly, there's a little over 1,100 CVEs are rated 6 and below. So, that's a big population that most folks aren't kind of paying attention to. We're going to use AI in this process to kind of figure out which ones of the 6 and belows should I care about, right? I think using CVSS to remediate 7s and above, that's a great idea. But which ones out of that 7 and below should I really pay attention to? And that's what we'll look at here next. Okay, so here's how we think about the process and which pieces are typically missing from vulnerability management processes. First off is coverage. So it's important to kind of understand risk in totality, right? It's not fair to look at just disclosed vulnerabilities and say, hey, that's my whole risk, because there's a whole nother component to that, right? That's these non-CVE vulnerabilities. Reserved CVEs are, maybe something's out there, but it's just not baked yet. We don't have all the details. We don't know if there's an exploit, so on and so forth. Malware, also something that we don't know about until it hits us in many times. And then the deep web and dark web type exploits that are traded out there that our tooling doesn't have visibility into. So the first puzzle piece is kind of having the coverage taken care of so I can understand my total risk as opposed to just focusing on kind of that cataloged risk. Once I understand that coverage piece, once I understand risk in its totality, looking at the whole universe instead of just a certain state, it's important to do some sort of correlation. So when we say correlation, it matters when we find these vulnerabilities, where we found them, for example. Did we find them in advisories? Did we find them on white hat research, so on and so forth? It matters who said it. It matters how much they said it. And then it matters, what's in those advisories. And we need intelligence to kind of stitch these things together, right? If I post an exploit on Twitter, probably not a big deal. But if there's known nation state hackers posting exploits on Twitter, that's something that has a little bit more priority. And then if I can correlate that with something from a vendor, from Red Hat, from Cisco, from Microsoft, something like that, where they know there's already a weakness, and we have a known nation state hacker talking about an exploit, then I can stitch those two things or stitch those two things together, and that makes for an even higher priority. So if you're reading the tea leaves, if you see where I'm going, I'm kind of anticipating what the priority should be based on all of these different pieces of information that I'm correlating together. Then the last piece, once I know who said it, where they said it, how many times they said it, what's kind of the importance, if there's a vendor advisory, then I can feed that into our AI models to make a prediction. I want to predict a couple of things. I want to predict its CVSS scoring, right? If your process is to remediate CVSS 7 and above, and I have a vulnerability that doesn't yet have a CVSS number, then I probably just leave it. But if I predict what that CVSS number is, then I can roll that into the pipeline and fix that vulnerability, even before it's been fully cataloged by the National Vulnerability Database. I also want to do a CWE analysis, right? I want to kind of understand, does it require authentication? What will happen if exploited? All of the different things that are required to make this thing happen. And then lastly, the likelihood of an exploit. I need to kind of know that as well. And that's what I can predict when I have all these pieces in the correlation piece. When I stitch them all together, I can predict the likelihood of an exploit, which is really important. And I'll give you just a non-AI example. If I find a flaw in Google Chrome that doesn't require authentication, that allows me to take control of your machine, right? The likelihood of an exploit being developed for that is almost 100%, right? We all know that inherently because Google Chrome is used everywhere. It doesn't require any authentication, and I can own your machine. Great. Let me get to work making an exploit. But that's what we're going to do with the artificial intelligence, is going to walk through that thought process that I just did and do it many, many, many different times, thousands of times over and over again, all day. Okay, so once we have those three pieces, I added a couple of points to it here where we are going to continuously assess. So it's very important to kind of know where we stand at any given time and do this in a low impact way. It's not acceptable in most environments to be running scans against production systems every day, all day. So we need a way to kind of do that, gather that information in a low touch manner. Once we have that information, then we can do those three things that I talked about on the previous slide. Ensure coverage, correlate with those different advisories, who said it, where they say it, how many times they said it, and so on. And then apply those AI models to predict the CVSS score and essentially say, how likely is this to be bad for me? That's where the AI kind of says what you should do now versus what you should do later. The last point there is just kind of prioritize them based on an algorithm that takes into account all of those things. Okay, so here is kind of under the covers on how we do it, and how other folks do it and how it's done. So first bullet point is NLP can help track thousands of unstructured sources of vulnerabilities, exploits, and threats. So NLP is natural language processing. Essentially, we're employing machines to go through and gather these blobs of data. And these blobs of data sit in blogs. These blobs of data sit in vendor advisories, in dark web chat rooms, on Twitter, wherever these exploits and vulnerabilities are published. The AI is going to go in and read them, essentially, just like a security researcher, just like you, me, anybody else would do that. Convolutional neural nets can predict CVSS scores, CWE, exploitability, as they emerge. So the way to think about this, the way that we're all familiar with, is kind of the AI we use to do facial recognition. We all know we can point a AI model at a picture, and it can pick out a dog picture, and it can pick out a cat picture. That's essentially what we're doing here, except we're pointing our models at these blobs of data we've gotten from the NLP and saying, hey, show me exploitability picture. Show me the weakness in the software, things of this nature. SVM-based models can help classify malware based on type, rating, and attack vectors. So again, we're gathering many of those different pieces that we're going to use to do that correlation that we do. And the SVM model helps us do that. NER techniques can help extract useful information, such as affected products, target countries, industries, etc., from the unstructured threat reports. So the best way to think about this is when you log into Amazon and you're going to go read through the reviews on whatever you're going to buy. Amazon does this. It pulls out the important parts of the reviews. It says, we've seen 10 reviews that say this product is high quality. And we've seen 20 reviews that say it's easy to use, right? And 30 reviews that say something else about it. What it's doing is it's going through those blobs of review data, which are very, very unstructured, and pulling out the important pieces. And this is great stuff. Amazon realized the need for it, and we've done the same thing with security, because what's the alternative? The alternative is for me to go through and read those 1,000 Amazon reviews and kind of try to correlate that in my head. Very, very difficult to do, but the ML models can do it quite easily, quite accurately, and quite quickly. So that's the NAR techniques. The document summarization techniques, such as TF-IDF, can cut down on the clutter and just present the useful summary from multiple threat reports. And the way to think about this is with, ML models, you want to provide the model the least amount of resolution to get the most accurate results. So we don't need 1 trillion data points if we can get accurate results with 100 or 10. All right, so this allows us to kind of cut down on that clutter so that we're just getting the right amount of data points to feed in the model to get the most accurate results. So we're using these 5 pieces, right, to do those things that were mentioned on the 3 puzzle pieces in like the 3rd or 4th slide, gathering that data. And just so you guys know, this happens throughout the internet. So all millions and millions of different data points from many different sources, we're applying this to. Okay. So let's go through a couple of real world examples here. Here's predictive CVSS scoring at work. We have a CVE that we just picked randomly. It's reserved, but we don't have any data, any details about it so far. So in your tooling, you probably don't know anything about it either. But what the AI has done is it has gone through and picked out all of those points to do that correlation. And what you'll see circled in red is a predicted CVSS score. This allows you to feed it in your process. You know that it's important to work on. And the important takeaway to this is we use AI to predict this score. This has not yet been published in the National Vulnerability Database, right? Pretty cool technology. Okay, exploit prediction AI at work is slightly different. Out of the 8,500 total vulnerabilities that we've discovered in the past 30 days, we're able to predict if there'll be an exploit for 657 of them. So that's really important. Again, that's in the same vein of taking that big pot of vulnerabilities and then distilling it down to a set that I can work on and make an impact on. And if you see here in the upper right-hand corner, what we've done is the AI model has predicted a likelihood of exploit, right? The same way I did it earlier in my example, Google Chrome, no authentication, own your machine. I'm predicting there will be an exploit developed. And we've done some benchmarking on these. These get very, very accurate. Just a side note, in the upper left, you see the CVSS score. And then you see down in the middle column, we have 9. And then when it gets published, it's an 8.8, right? So it's very, very accurate, very, very close to what actually gets published. So these models work great. Okay, malware. So malware matters only because it doesn't take a human to own you with malware, right? It kind of spreads organically, which is great for the attackers. There's not much keyboard time involved with them, but it's bad for us because it just comes to us naturally. All right, we don't have to be targeted by a nation state actor. Malware will make its way into our organization. So it's very, very important to kind of understand what vulnerabilities are associated with malware, and our correlation model does just that. It catalogs those vulnerabilities with exploits that have been weaponized. And here we have the 130. So we looked over the past year, we say out of all the vulnerabilities that we have discovered, these are the 130 that matter. So essentially for your organization, these are the do first. If you do these first, then you've essentially inoculated yourself from these organic malware that are coming your way almost certainly. Of course, there are other vulnerabilities. Of course, there are nation state actors that are going to hack you in a kind of a manual way. But these are the kind of low-hanging fruit, if you will, that you should go for first and then work your way back to the rest of the vulnerabilities. Okay, so we like to kind of coin this or name this proactive security Nirvana, and it's a spectrum, right? It goes from those 40,000 that are disclosed to the 10,000 that are 7 or above, the 7,000 with no tracking, the 6,000 with known exploits, and then the 1,000 that are likely to be exploited. And what when you have this information, it allows you to do is work backward. So instead of working from the 40,000 and working your way right on this chart, you can start at the 1,000 and work your way left on this chart. And I'm forgetting there the 130. So that's the ones that we discovered on the prior slide that you should absolutely do now. And then you work your way back on this chart, right? The part that's great about this is, if you do any reporting to your board or anything like that on vulnerability remediation, you can make an impact on that 130 number. You can't make an impact on that 40,000 number. So I see a lot of people produce these charts and they want it to be a hockey stick showing vulnerabilities going down, and it ends up being a flat line. That's because they're working from left to right, whereas if they're working from right to left, then you can affect those numbers a little bit more. Okay, so this is my last slide. I'll tell you a little bit about ThreatWatch. We kind of pioneered this AI technology that gathers all of these things. The very best thing, the biggest value add is that machine curated threat intelligence. So we're doing all of those puzzle piece things with the AI components that get this information. Once you have the information, it's easy to do a prioritization. But that is kind of the big value driver of this platform. It gets you the information quicker, earlier threat detection because we get it before it's been published, but also allows you to remediate quickly as well. It's good for DevOps, cloud, third-party assessments, many other use cases. The other great thing about ThreatWatch is it's agentless and scannerless. So, you know, we don't have these big noisy scanner appliances, you know, using your network bandwidth in your data center. Additionally, we don't have this heavy real-time agent that sits on your laptop and slows it to a crawl as well. We do it with a simple open source component script, kind of gathers this information and allows us to continuously assess that machine while it's out doing what it should be doing, which is, you know, working for your organization. Okay, and that's all I have for today. I thank everyone for joining and coming to work with us today. If there are any questions, please feel free to unmute yourself now and you can ask those questions live. I've got a bunch of technical folks on the phone that are happy to answer those questions. Alternatively, you can post them in the chat window and we'll answer them as well. Are there any questions? And with the, looks like we have 2 minutes remaining. Ketan is our CEO. If you'd like to, you know, answer anything or pop in there and fill in any pieces that I miss, I'll give you the last 2 minutes.
Thank you, Jonas.
Sure.
I hope this was useful to everyone who attended. We'll be posting a recording of this. You can go through it, review it, reach us through our website, drop us a note on LinkedIn or from wherever, and we'll be happy to continue the conversation.
All right. Thanks a lot, Ketan. Thanks everybody for joining. And again, if you'd like any more info about this, you can visit threatwatch.io or drop us an email at info@threatwatch.io. Thanks everybody. Have a great long weekend and we'll talk to you soon.